Okay, this will be the third lesson in Unit 2 for pre-calc. This is going to be on composition of functions. Before we get into the composition of functions, I want to go over some regular function operations. Let's say you had these two functions, f of x and g of x. What this means is I would add f of x plus g of x, okay? Just got to be careful with your like terms, okay? So if you want to distribute, it makes it a little easier. That's going to be 8x and 6, so I treat that like a positive 1. 12x minus 4, okay? My like terms, 12x and 8x would be 20, and then negative 4 and 6 would be 2, okay? That'd be my answer there, okay? Subtraction, okay? And I'll show you how this is a little bit different than the common mistake people make, okay? What you want to make sure you do, go ahead and treat this like a negative 1 and distribute it, because that way you understand the sign change when you combine your like terms. Some people, what they'll do is they'll combine that as a positive 6 over there, okay? So 12x minus 8x would be 4x. Negative 4 minus 6 would be negative 10. So that would be my answer, okay? So what I'd like you to do is pause the video, all right, and see if you can do question number 3 on your own. Okay, unpause, okay? So g of x would be 8x plus 6 minus 12x minus 4. All right, I'm going to go ahead and distribute that negative 1. Negative 12x, negative 1 times negative 4 would be positive 4. Okay, if I combine those two, 8 minus 12x, I get negative 4x. 4 plus 6 would be 10. Okay, and that's my answer. Simple operation deal. Okay, now let's move on to composition, okay? All right, so you have two types of composition. You have composition where, if you notice, you have a number at the end, okay? And the other one, okay, where you have a letter, all right? There's basically two ways composition is shown. It is either shown with all those things like this, or this O means composition, okay? So if you get confused, that's what that means, okay? Now, there's a little bit different of a process for the number opposed to when there's a letter at the end, okay? If there is a number, I think this is the easiest way to do it. I'm going to pretend like the F is not there, okay? So the idea is, we did this in the last unit. G of 5 means put 5 in for x, okay? So I'm going to put 5 in for x, okay? I'm going to figure out what that is. 2 times 5 would be 10. 10 minus 4 would be 6. Okay? And then I just go ahead and find f of 6. Okay? So then the result there goes for f. So I'd put 6 in. That'd be 60 plus 3, which would be 63. I think that's the easiest way to do it. Okay? So when you look at this one, what you want to do is pretend like the h is not there. Okay? So I would do j of 29. Okay? So I would put 29 in for that. 29 minus 4 is 25. Square root of 25 is 5. So then now I'm going to find h of 5. Okay? So I use the h function. 5 squared plus 6, that's 25 plus 6, which will be 31. Okay? I would keep it as simple as that. Okay? Evaluate the closest part. Whatever the result is, then evaluate the next letter. Okay? Now, the letter, when you have a variable at the end, this is a little bit different, okay? You're going to work in a different way. So before we went this way, okay? All right, now when you have the letter at the end, what you're going to do is, this is important. So when you have the variable, you're going to start with this function, okay? So what I'm going to do, okay, when I have a letter at the end, if I have a letter, I'm going to start with this function. And every spot where that function, so in this case it would be g, for every spot there is an x, I am going to put a parentheses. So as you can see, there's an x right there. I'm going to leave a blank spot. This function is what you fill into the parentheses. So in this case, I would fill 10x plus 3, because that's the f function. Okay? Then I want to do an operation, okay? And those operations are going to be different depending on the problem. In this case, I can distribute. That'd be 20x plus 6 minus 4 If I combine the like terms there, that would be 20x plus 2. Okay, because those are the only two that combine. Okay, so a little bit different a process. So on this one, what I want to do is I want to start with the j function. So with the j function, I'm going to put a blank spot where that is. Okay? All right. Then what I'm going to do is I'm going to insert, in this case, would be the f function, 10x plus 3. Okay? I'm going to look to combine my like terms here. So what ends up happening is the only like term would be that, would be 10x minus 1. And this is as far as we can go. We cannot go any further. Some people will try to take square roots of both things. Just leave it as it is. You cannot reduce that binomial. Okay? All right, now, this function, all right, I want to start with h. So squared plus 6. Notice I have taken the parenthesis right there. What am I filling in? I'm filling in the f function. Probably should have done the g function. That's okay. All right, let's go 10x plus 3. All right, now, I got to do an operation, okay? Last unit, we did a ton of stuff with the squared thing. What we know about that is that means 10x plus 3, 10x plus 3. 10x times 10x would be 100x squared. 3 times 10x would be 30x. Same thing over here. And I got 9, okay? So I got 100x squared plus 60x plus 9. And I also have this plus 6 over here. Not as many like terms as last unit. This is 100x squared plus 60x. These are my only like two, which would make that 15, okay? So a little bit different of a function here, okay? All right, you start with this function, and the second one you fill in, okay? Here's what I'd like you to do. All right, here are your functions here, all right? I would like you to pause your video, okay? Work on these and then unpause. Okay, so unpause. So my number, all right, so I'm going to work f of 8 first. Okay, so I'm going to use the 8 function, the f function. That's going to be 40 plus 9, which is 49. Okay, all right. Then I'm going to take this result and do that for g. Okay, so 3 times 49 minus 12. I'm going to go ahead and use my calculator for that. It's a little bit of a big number. 3 times 49 minus 12 is 135. Okay? This one, I'm going to do j of 8. I'm going to work with that one. So I'm going to use my j function and put 8 where x is. So that's going to be 9, give me 3. So now I'm going to work h of 3. Okay? 3 squared minus 4, that's going to be 9 minus 4, which would give me 5 as a result. I would keep that as simple as I could. Okay? Now, so what this is going to be, I'm going to start with this function. So I'm going to start with f. I'm going to put a blank spot where the x's were in that function. This is going to be my fill-in function. I'm going to put 3x minus 12. Now in this case, I just have to distribute, which would be 15x minus 60 plus 9. These are the only like terms, so 15x minus 51. Okay? This would be my start function on this one. Okay, j. So I'm going to do this, blank spot where x is. Okay, this will be the fill-in function. Okay, so I got x squared minus 4. Okay, the only terms that can combine there, okay, are the minus 4 and the 1, which would give me 3. And I'm going to go ahead and stop right there for that one. Okay, this one, this is going to be my start function, h. This is going to be the fill-in function, f. Okay, once again, this squared means make this little box, 5x plus 9, 5x plus 9, that's going to be 25x squared, 45x, 45x, and 81, okay? All right, so I got 25x squared plus 90x plus 81, and this little minus 4 over here, the only things that combine are those, so 25x squared plus 90x plus 77. Okay, all right. That gives us a good foundation so far for composition. Okay, so Now we're going to talk about finding composition and then finding the domain off that composition. Okay? Now, this one, just like before, this is going to be my start function. So I got 4 over, I'm going to put a space where x is. This is going to be the fill-in function. Okay? All right? Now, there's no operation that can take place, so this would just be my result. Okay, so let me talk about domain. Now, we talked about the square root function, okay? If you remember back, okay, when we were doing the table, okay, the square root function looks something like this, right? And let's say this was a 2 and a 5, okay? If I was finding the domain, okay, on something like this, this would just be 2 is the smallest x, this is the biggest x. Now, here's what I want you to understand conceptually, okay? We understand that, okay? We understand that when I have a fraction, underneath the fraction cannot be 0. It cannot be 0. Cannot be 0, okay? So, all right, what that means is, okay, what that means is my part, when you have a square root under the denominator, okay, this interior part, okay, has to be greater than 0, okay? Cannot be 0, and it can't be negative. I probably should have said that too, okay? All right, so the only way something cannot be 0 and negative, it's got to be positive. So this would be the best example of that. So if I do plus 3, okay, I've got x is greater than 3. Well, on a little number line here, we know this. We worked on this last unit. How would I write that? I would say, okay, that's going to be, the domain's going to be from 3 to infinity. Okay? So, the big takeaway, if you have a square root in the denominator, the part underneath the square root has to be greater than 0. It cannot be 0, and it cannot be negative. That's only for ones that are in the denominator. Regular ones, it can be 0, okay, but not for those. So that would be the domain for this one, okay? Now let's go ahead and do this one. H of g of x, okay? So we're going to start with h, okay? I took out that. I'm going to put in g of x, okay? Now, a little computative trick. If I square a square root, what ends up happening is the square, they basically cancel each other out. Now, if I combine these, this is what I have. Okay? All right? So, this would be my answer. Okay? Now, what is this a shape of? This right here, to find the domain, is a line. Now, here's what we know about lines. Lines either look like this, or lines look like this. Okay? And this is the same for all odd functions. Okay? All odd functions, okay, are going to have, okay, our odd power, that's probably what I should say, odd power functions, are going to look something like this. Okay? Well, how do you find the domain? Negative, negative, positive, positive. Well, what about this one, Mr. Evans? Well, that would be a negative, positive, and this would be a positive, negative. Now, either one, watch what happens. The smallest x value is negative infinity, the biggest is positive. Okay? Now watch what happens when I go over the other line. Smallest is x, biggest is positive. So no matter what your lines are, that's what you get. So what you want to do with the domain is sometimes look back at the parent functions. The parent functions can help you figure out what the domain is. Okay? The parent functions are great for the domain. Okay? So, what I'd like you to do, okay, is go ahead and pause your video and go ahead and work through these two functions, problems. Okay, unpause. All right, so here will be my start. Here's what I'm going to fill in, because I got this x at the end. 2 over, blank spot. This is just going to be 2 over square root of x plus 7. Okay? Now, to find the domain, we know that that part underneath has got to be greater than 0. So if I do a simple subtraction, x is greater than -7. Okay, so what would that look like from an interval notation? -7 to infinity. Okay, let's go to this one. This is going to be my start. This is going to be my fill-in because I got this x at the end. Okay, square root. All right. X, oh, whoops, I'm sorry, parentheses, plus 7. I go ahead and fill that in. Squared minus 4. Okay, so I got x squared. Basically, I combine like terms here. Okay, now, here's where you have to think a little bit. Okay, here's where you have to think. The concept of this, okay, all right, how do I know the domain of the square root? I know that okay, this is a great problem here. Let me change this. Let me change this briefly. Let's say, let's change this to a plus 4. Let's change that to a plus 4, because that other way is not gonna show a great example. Let's go back real quick. Okay, so sorry if you're doing that video at home. Let's do this again. Here, all right, put in this x squared. That's not. Sorry, we'll leave that as, we gotta change that one. Let's change this to, let's go to minus 14. That might be easier. Okay, that's gonna work out. All right, so let's start that over again. Sorry, square root plus 7, put in x squared minus 14. If I combine those, I get this. Okay. Now, we know that this has to be, in our other problems, was greater than 0. However, since this is not in the denominator, I can go ahead and do this, okay? So I got x squared, I would add 7, so greater than or equal to 7, okay? Take the square root of this, plus or minus. Okay, so x is greater than or equal to plus or minus the square root of 7. Okay, all right, so what does that mean? Okay, x has got to be greater than, okay, square root of 7. And the other part is x is going to be less than negative square root of 7. Okay, all right, so how would we do that interval notation? That interval notation would be from negative infinity to negative square root of 7. Union square root of 7 to infinity. Okay? All right. Now, these last ones, okay? These last questions. All right. Given f of g of x, all right, find f of x and g of x. So what you have to really look at is there's a lot of different answers for these, okay? So the idea would be is like something simple like this. Okay, let's say that, okay, all right, was my f of x. If I was doing the composition, what would happen is this is what my result would be, right? Now, what could go in up here that would give us that? Well, that's an easy answer. That would be x plus 3, right? Now, but if I put that here, I wouldn't get 9. So how could I make this so when I would put this in, the numbers would be combined to 9? And the simple answer would be, just make that plus 6, okay? So now, if I combine those, I would get 9, okay? So this is one of those sort of critical thinking questions, okay? So go ahead and pause your video and see if you could come up with this other one, okay? So what I might start with is this, okay? So what would go in up top? Okay, so it would be like f or would be, I'm sorry, would be parentheses, okay, with the square root, right? So if I put that in, that helps me there, okay? But the problem is if I put that in there, I don't quite get minus 3. So how could that become minus 3? Just go ahead and take a 2, okay? All right, and that's how simple that one is, okay? All right, I'm probably going to go back in class and change this problem because I don't want you to have to do that, but that's how you would do that problem. But that's going to be the first lesson on composition.